Welcome back, friends. Now we are in assignment number 9. We'll do the theory part first. Yeah, so it's all about definite integration. Assignment number 9. So we have been studying about integration, and till now we have been adding that integration of constant c, right? Today we are going to get into the finals of it, definite integration. So what is it? So till now we have been studying integration, right? So say integration of small f of x dx is capital F of x, right? This we have been doing for a long time. Well, last semester we did f of a and f of b. What are they called? Functions value at point A and functions value at point B, right? Well, so now using this we are going to define definite integration. So what is it? Till now we had just x without any restrictions, and that's how we had constant of integration. But now we will be having x with restrictions, that is small from upper limit from smaller limit to the upper limit. So from a to b, a is written in the lower side, b is written on the top side. So integration of f of x dx from a to b. So we know how to integrate. So we integrated capital F of x and the limits are from a to b, and the value is the difference between f of b with f of a, f of b minus f of a, right? So this is simple because we have been doing a lot of tough integration also, and the definite integration is just the difference between uh, the functional values from upper limit minus the lower limit. So for example, the first sum is, we have that question number 1, right? Integration of x square dx from 1 to 2. We know how to integrate x square, that is x cubed by 3. And the limits say that from 1 to 2. So let us substitute the limits. It's 2 cubed by 3 minus 1 by 3. That is 8 minus 1, that is 7 by 3. That's the answer. It's quite simple, right? Second one is 0 to pi by 2 cos of x dx. So integration of cos is sine, we know that. And the limits are 0 to pi by 2. So substitute the values, find out the difference between the functional values. Sine pi by 2 minus sine 0, that is 1 minus 0, that's 1, right? Yeah, I jump to the question number 14th. 0 to 5 integration of dx upon x square plus 2x plus 10. So this is what we did in the partial fractions, right? Completing the square. So it's 2x, so it is going to be x plus 1 the whole square, right? Remaining is 10 minus 1, so that gives you 9. 9 is 3 square. So everything remains same, 0 to 5 dx upon x plus 1 the whole square plus 3 square. So the formula that will be used is 1 upon x square plus a square. So we have tan inverse of x by a, 1 upon a. So 1 upon 3, tan inverse of x plus 1 upon 3. Limits ranging from 1 to 5. As we substitute the values, upper limit minus lower limit, we get tan inverse of 6 by 3 minus tan inverse of 1 by 3. Outside is 1 by 3. So that is tan inverse of 2 minus tan inverse of 1 by 3. You may use a calci or you may use the tan inverse formula. So what do we get? 1 by 3 tan inverse of 2 minus 1 by 3, 1 plus 2 into 1 by 3. That is 1 by 3 tan inverse of 5 by 3 upon 5 by 3. So it gets cancelled. You get tan inverse of 1. That is 45 degrees. 1/3 of that is 15 degrees. So that's the answer. So from simple or complicated sum, it is just integration, substitution of limits, and find out the difference. That's the integration, definite integration value. Right? Now there is another topic which is called change of limits. Is it a new topic? No, it is just our age-old substitution, the most important, the most often found technique of integration. Only thing, why is it called change of limits? We substitute, we get into a new variable, right? So the old limits of integration, how can they be carried out for t t or a new variable. So we change limits for t. So new limits are found out for t. And that's what it is called a change of limits. Look at this sum. Question number 15. 0 to pi by 2. न्यूमरेटर में sin x dx है, डिनोमिनेटर में 1 प्लस cos x का क्यूब है. सो वी नो व्हाट रिपीट्स, और जिसका डेरिवेटिव दिखाई दे रहा है 1 प्लस cos x का डेरिवेटिव दिखाई दे रहा है, उसको सब्स्टिट्यूट करेंगे t, and we have minus sin x is equal to dt by dx, right? Substituting we get what is remain? Change of limits has remained. So x का लिमिट 0 to pi by 2 है और t है 1 plus cos x. t है 1 plus cos x. तो when x equal to 0, t is equal to 1 plus 1 is 2, and when x is equal to pi by 2, t is equal to 1 plus 0, that is 1. So first time we are having that at lower limit it is bigger value, 2 to 1, right? So here it is 2 to 1. न्यूमरेटर में माइनस डी टी, डिनोमिनेटर में टी क्यूब, दैट इज टी रेस टू माइनस 3, राइट? तो इंटीग्रेशन में आएगा माइनस वैसे का वैसा रहा, ऊपर आएगा टी रेस टू माइनस 2, नीचे आएगा माइनस 2. लिमिट्स रेंजिंग फ्रॉम 2 to 1. माइनस माइनस गेट्स कैंसल्ड, वी गेट 1 upon 2. Oh, I made a mistake. It is 1 upon 2 t square, right? It is 1 upon 2 t square. Substituting the limits, you have 1 upon 2 outside, inside bracket 1 minus 1 by 4, that is 3 by 4, 2 into 3 by 4, 3 upon 2 into 4, that is 3 by 8. That's the answer given in the book, question bank, right? Well, now similarly you have to do 16, 17, and the 18th one is bit complicated. What it says, 0 to 1, x tan inverse of x upon 1 plus x square raised to 3 by 2 dx. It's quite confusing what to substitute for, but of course you see the complicated thing is tan inverse of x. Why? उसका डेरिवेटिव 1 plus x square दिखाई दे रहा है. Yeah. So what do we do? x tan inverse of x, dx के नीचे 1 plus x square ले लिया, उसका जो tan inverse x का डेरिवेटिव है, बचा हुआ 1 plus x square raised to 1 by 2 साइड में लिखा है. Substituting tan inverse of x is equal to t, so that means x is equal to tan t. The derivative, if I differentiate both sides, I get dx upon 1 plus x square is equal to dt, right? और क्या क्या अपने पास x हो गया, tan inverse x हो गया, dx भी, dx upon 1 plus x square भी हो गया, बचा 1 plus x square raised to half. 1 plus x square raised to half is left out. तो 1 plus x square is equal to be sec square t. उसका स्क्वायर रूट बोला तो sec t हो गया, right? Well, x ranges from 0 to 1 and t is tan inverse of x. So tan inverse of 0 is 0, tan inverse of 1 is pi by 4. So t has values 0 to pi by 4. 0 to pi by 4, x की जगह पे tan t, tan inverse x की जगह पे t, dx upon 1 plus x square की जगह पे dt, और डिनोमिनेटर में 1 plus x square is to half की जगह पे sec t. Now tan को लिख रहा हूँ sin by cos, ऊपर t, sec को लिख रहा हूँ 1 upon cos. So cos gets cancelled. I just have to integrate t sin t. Do you remember? We did it by integration by parts. I think question number 1 or 2. Well, so what do we do? We integrate by parts. U is equal to t, जिसका डेरिवेटिव होगा 1. V is equal to sin t, जिसका इंटीग्रल होगा minus cos t. तो u इंटीग्रल ऑफ v t minus cos t minus whole integral 0 to pi by 4. डेरिवेटिव ऑफ u is 1, इंटीग्रल ऑफ v is minus cos t. तो पहले का तो ऑलमोस्ट हो गया है, दूसरे का माइनस माइनस प्लस कॉस टी का इंटीग्रल है साइन टी, रेंजिंग फ्रॉम 0 to pi by 4. Substituting the limits, minus pi by 4 cos pi by 4 plus sin pi by 4 minus 0 plus 0 doesn't matter. तो minus pi by 4 into 1 by root 2 plus 1 upon root 2 and 1 up, that is equal to 1 upon root 2 taken common, 1 minus pi by 4. Right? Go through it carefully and let me know. Thank you. Tomorrow we'll do definite integration, properties of definite integration. Thanks.